Alright, so in this example, we are asked to find the 6 trigonometric functions of the angle whose terminal side contains the point 5 comma negative 7. So note, we aren't told what the angle is in degrees, we're not told what it is in radians. All we're told is that when we draw it, its terminal side will have this point on it. It'll have many other points as well, but at least this is one that we know for certain. Now, I think it's a great idea to draw a picture for any type of problem like this. So I'm going to go ahead and insert a blank set of axes here. And what I'm going to do is I'm going to draw the angle in question. So for instance, I'm just going to kind of eyeball where the point 5 comma negative 7 is, and we'll do that in hot pink. So I don't know, 5 comma negative 7. We'll call it there. Now, let's talk about the angle whose terminal side contains it. Well, we know that all angles, their initial side, looks exactly like that. Now, we don't actually know if this is a positive angle, a negative angle, whether or not it's gone around the circle a whole bunch of times. All we know is that its terminal side will contain that point 5 comma negative 7. Maybe it's the case that it's just a small negative angle. Maybe it's kind of a larger positive angle. Maybe it's gone around the circle a couple of times and made its way over here. Who knows? Who knows? We don't know. Why don't we just say that we're talking about this angle right here for now. So we're going to call this angle theta. We're just going to give it a name. Now, I think it's a really good idea for any problem like this to go ahead and draw what I call a reference triangle. What does that mean? It means take our ordered pair and draw a line directly to the x-axis. And I hope you can agree that we kind of get, or we do get, a right triangle in this case. And I think triangles are wonderful. They make me more comfortable. I can use the Pythagorean Theorem. And for instance, with this triangle, I know that this side right here has a side length of exactly 5. And I know that this side right here has a side length of exactly 7. Note that the y-coordinate is negative 7, but the length of this side of the triangle is 7 units. So the first thing I want to do is I want to find this r business right there. So I'm going to use a little Pythagorean Theorem. I'll do this right below the graph. So I know that that distance squared will be equal to, you can either use the lengths of the triangle, so 5 squared plus 7 squared, or you can use the coordinates of the ordered pair. And note that it's not going to make a difference because that negative 7 squared is the same thing as positive 7 squared. So I'll just go ahead and use the sides of the triangles. Alright, so our radius squared will be 25 plus 49. Our radius squared will be 74, so our radius will be the square root of 74, whatever that is, 8 and a little bit. So I'm going to go ahead and label that right here. Our radius is the square root of 74. And now here's the deal. I think we are ready to go ahead and actually find the sine, cosine, and tangent, etc., of this angle theta. Now for some people, they really like to think about this angle in here more. Go for it. Go for it. There's just going to be one small difference at the end. So if you want, we can call this little inside guy, we'll call him beta. Okay. So I think that by definition, the sine of our angle theta is going to be equal to its y-coordinate over the radius. Now its y-coordinate happens to be negative 7. So we've got negative 7 over our radius, which is the square root of 74, and there we go. That is our sine of theta. Our cosine of theta will be our x-coordinate over that radius. Our x-coordinate happens to be 5, and our radius is the square root of 74. And the tangent of our angle theta is the y-coordinate over the x-coordinate, excuse me. And I think that's going to be negative 7 over 5. And from these three, we can find the cosecant, the secant, and cotangent. No problem. Note that the only difference between sine, cosine, and tangent of theta, this guy right here, and if we wanted to find the sine, cosine, and tangent of beta, this guy right here, the only difference is beta's sine would be just 7 over root 74. instead of thinking about it in terms of coordinates, negative 7 over root 34. And the tangent of beta would just be 7 over 5 instead of negative 7 over 5. So that's the only difference there. And that's the strategy that I would go about using anytime that we are asked to find the trig functions for an angle whose terminal side contains a specific point.